Okay, curve C passes through the origin, find dy over dx at the origin. Okay, so what we're going to do first of all is I'm actually going to try and differentiate this one here. Okay, but of course that's in regard to x, so when we do differentiate this, we're not going to get dy over dx, we're going to get dx over dy. Okay, sine turns into cos, keep 2y, and you normally times by the y coefficient, but because we've got the 4, that makes it 8. Dx over dy, we flip it over to be dy over dx, to be 1 over 8 cos 2y. This is important, we might need this later. Now we want it at the origin, so we know at the origin x and y is 0. We've got a y there, so what we're really doing, we're doing 1 over 8 cos of 2 times 0. 2 times 0 is 0, cos of 0 is 1, so that turns into an 8th. Okay, so my gradient is 8th at the origin. Okay, right, now what we need to do is we need to show that all points for x and y lying on C, dy over dx equals this craziness. We need to find a and b. Okay, now we're going to start with dy over dx, yeah, just because that's what it's asking us. And we know that's 1 over 8 cos 2y. Okay. Now, it's not obvious, but what we need to do really, we need to use the formula cos squared x plus sine squared x equals 1. Because I can rearrange this to make cos squared cos of the subject. Okay. So what I'm going to do is I'm actually going to do cos squared x equals 1 minus sine squared x. And I'm going to square root it, so I know cos of x equals the square root of 1 minus sine squared x. And that's sort of looking like similar to like what we're trying to aim for. Okay. So I'm just changing my colours for no reason. So let's see what I've got when I substitute this in. I've got 1 over 8, and cos of 2y, if I use this formula, I can change that to the square root of 1 minus sine squared of 2y. And again, you might think, well, what's the point of that? Well, because is there something like sine squared of 2y that I sort of know? Well, here, I know there is a sine of 2y. So if I rearrange this, I've got x over 4 equals sine of 2y. Now, I can substitute that into this equation at the bottom. Okay, which can be 1 over 8, then the square root of 1 minus, so remember, sine of 2y is x over 4. So sine squared must be x over 4 squared. Let's draw this line here now. We've just got to do a little bit of rearranging here. So it's 1 over, now this 8, I'm actually going to change to the square root of 64. Because then I can times that by 1 minus x squared over 16. And I've got x squared over 16 by squaring the top and the bottom. So it goes all the way across. So I've got 64 minus, now I'm doing 64 times x squared over 16. Yeah, which actually then gives me 4x squared. Yeah, so that's going to be 1 over all of that. Okay, where we're trying to get to. So I need to factorise out a number. I can clearly factorise 4 out. Yeah, the square root of 4, I should say. So I've got the square root of 4. Okay, and then all of this over 1. Yeah, and then if I open my brackets, I've got the 64 divided by 4. The square root of 16 minus x squared. Okay, so I've got 1 over 2 brackets 16 minus x squared. And that's my answer.